Hey there, STEM chemistry students. This is Ms. Ruark. This is Vodcast 2.1, where we're going to start looking at how atoms bond and why they bond. And in order to figure that out, we need to get into some basics on bonding. So, looking at this table right here, I'm only going to go through a couple of these with you. You should be able to do the rest of them on your own, but you need your periodic table in front of you. And so if we were to do chlorine, we would say that the atomic where's my pen? There it is. Atomic symbol, or the element symbol for chlorine, would be Cl. The total number of electrons for a chlorine atom would be the total number of protons, because it's an atom, and an atom means that it is neutral. And if it's neutral, it has to have the same number of protons as electrons, right? All right, so total number of electrons would be 17. Total number of valence electrons, well, it has 7 valence electrons. Why? Because it's in the halogen group, right? We've shown it several different ways for you to figure out how to do the number of valence electrons. All right, if it has 7 valence electrons, it wants to be just like argon, which is the noble gas right next to it. So is it going to gain 1 electron or give away 7? Well, remember, atoms are just as lazy as students are, and they want to do the least amount of work for the most amount of gain. So it would be easier to go and take 1 electron. So they're going to add 1 electron on. If they gain 1 electron, the oxidation number, or the charge for this, would be a 1 minus. Right? Because remember, electrons have a negative charge. So you're adding a negative. All right, let's look at let's do sodium. Okay, so sodium symbol is Na. How many electrons does it have? It has 11. How many valence electrons? Well, it only has 1. So sodium, being the sodium atom that it is it going to want to take on 7 electrons so it can be like argon? Or is it going to want to just give away 1 on the street corner? Hey, who wants an electron? To be just like neon? Well, I don't know about you, but I think it would be easier to find somebody to dump an electron on than it would be to go and find 7. So it's going to give away 1 electron. And if it gives away 1 electron, it's going to have a positive 1 charge. Why? Because it has 1 more proton than it does electron. Okay. Are we okay with that? I hope you are. Do I need to go through all of these? I hope not. But what I want you to do is, if you are unsure of this, now that I've shown you how to do it, I want you to go through it on your own and try it and see how you're doing. Okay, we've already talked about charges for each of the ions. And once you finish this and you're unsure, bring it to me and I'll check it for you. All right, moving on. Okay, so we've talked about this. We said an atom that gains 1 or more electrons will have a positive charge. Electrons would have a long morning so far. Negative charge. Sorry, it's gaining an electron. It's going to have a negative charge. If it loses 1 or more electrons, it will have a positive charge. I know that one's correct. All right, an atom that gains or loses electrons is called an ion. Okay, so we don't call it an atom if it has a charge. We call it an ion. And a positive ion, we call it a cation, not a cation, but a cation. Remember, cats have paws and they're positively. Positively, yes, okay. And a negative ion is called an anion. I don't really have one for that. Maybe onion, but yeah. All right. So forming ionic compounds. Ionic bonds form when electrons are transferred from one atom to another. Okay, and when they transfer these, they form ions. The bond represents the attraction of a positively charged particle and a negatively charged particle, and each atom is left with a full outer shell or energy level. An ionic bond forms between a metal ion with a positive charge and a non-metal ion with a negative charge. Why? Because metals make positives and nonmetals make negatives. All right, so examples of these would be if sodium and chlorine came together to make a bond. You would have sodium with a +1 charge and chlorine with a -1 charge. All right, well, you need 1 and 1. It's going to be a ratio, so you would have NaCl, or sodium chloride. if you have magnesium and iodine, magnesium has a +2 charge and iodine has a -1 charge. To cancel those out, because every compound has to have an overall charge of 0. Net charge 0, 0. They're neutral. All right. So in order to cancel this out, I have a +2 charge. Well, I would have to have 2 iodines for every 1 magnesium. Okay, potassium has a +1. Iodine has a -1. That's a 1-to-1 ratio, so we're okay there. Sodium and oxygen. Sodium has a +1 and oxygen has a -2. So to cancel that out, I'd have to have 2 sodiums for every oxygen. And you see how we're going here. You can finish the last 2 on your own. Okay. So what do these atoms look like? Or these, what do these atoms look like? Well, if it's an ionic compound, it's going to be very neat and orderly. It has a nice, pretty structure to it. Everything is just beautifully aligned and structured and repeating patterns. Okay, and that's how you get to these pretty, pretty crystals. Okay. All right. Properties of ionic compounds. They're usually solids at room temperature. They have extremely high melting points. They are good conductors of electric current when they are melted or dissolved in water. They are highly, can't remember what I put here, I'll come back to that one. Ions arranged in regular repeating pattern called a crystalline structure. They're made of formula units. Highly, I think I put dissolvable here, but I can't remember. I make them and then I forget what I'm putting. All right, so they're made of formula units. They're not true molecules, and it's because you have a ratio of the positive to negative ions. In a molecule, you have a set number of one atom to another atom. All right, so in a molecule, which would be a covalent or a molecular compound, these are formed by the sharing of electrons. Okay, and atoms will share to form a single, a double, or a triple bond to satisfy the octet rule for each atom, except for hydrogen. Okay, what's the octet rule? 8 valence electrons. Okay, so they're still trying to be just like the noble gases, but instead of transferring and trading electrons, they're now sharing them. And that's where the electronegativity comes into play. All right, properties of covalent compounds. They can be solids, liquids, or gases. They tend to have lower melting and boiling points than the ionic compounds. They're not always soluble in water. See, it was soluble or dissolvable. Okay, they're not always soluble in water, and they are poor conductors of electricity. So we would call them insulators. Okay, metallic bonding. Metals have closely packed cations with a sea of electrons freely moving around them. Oh, sea of loose electrons. Sorry. All right, metallic bonds form due to the blank of free-floating valence electrons for the positively charged metal. I don't know. The sharing of freely floating valence electrons has to be what goes in there, because I can't think of another word that goes in there. Okay. All right, so crystal structures of metals allow for close packing of cations. So what happens here is you have all these cations or metal ions that come together, and the sea of electrons is the electrons are just kind of free floating and sharing, and that's what allows for the good conducting ability of a metal, is that those electrons are able to transfer from one cation to the next cation to the next cation. Okay, now you have a couple different ways that these metals can be formed or structured. You have your body-centered cubic, which makes a cube, body-centered. You have the one in the middle. Okay, and then you have your face-centered cubic, which means that instead of having the one in the middle, you now have them the one on the face of the cube. So it's still a cube, but you have the little ions in the middle, or the electrons in the middle float. Let me say that again. You have your cations forming cubes, but then you also have them on the face of each cube side. Okay. Then you have your hexagonal close packed, which means that you have a hexagon Here's your hexagon of molecules with, or of cations with another cation in the center, and then they are closely packed with another hexagon. This would be another hexagon going that way, and they're all extremely closely packed. Okay. All right, properties of metals. They are excellent conductors of heat and electricity. They are ductile, which means that they can be pulled into wires. They are malleable, which means that they can be hammered or forced into shapes, and they crystallize in characteristic patterns due to their body-centered cubic, their face-centered cubic, or their hexagonal close-packed structure. Okay. Determining the type of a compound. So if it has a metal bonded with a nonmetal, it is going to be an ionic compound. If it is just nonmetals, nonmetal bonded with a nonmetal bonded with a nonmetal, it's going to be a covalent or a molecular bond. And if it's just metals, it's going to be a metallic bond. That's pretty easy, right? So you need to make sure you know the difference between metals and nonmetals. All right, so examples of these. How can you tell? All we're going to do is tell if it's ionic or covalent. So looking at this, this has a metal listed first, so it is an ionic compound. That easy. Iron is a metal, so it's an ionic compound. Carbon is a nonmetal, so it is a covalent compound. Nitrogen is a nonmetal, so it's covalent. Copper is a metal, ionic. Nonmetal, covalent. Nonmetal, covalent. Oh, here's bronze. It's an alloy of copper and tin. This would be a metallic, and we call it an alloy. It's not actually a bond. We call it a mixture. But it would be considered a metallic because it has copper and tin together. Oh, and I didn't give you a chemistry cat. How sad. I got a sad face on right now. Okay, well, I will see you in class.